So the next part of section 1 is talking about absolute values. So that's what we're going to do. But to start that, we're going to talk about the real number line. So we've talked about what real numbers are. Real numbers are going to be any numbers that you can write as a decimal. What we can do is we can plot them on a real number line. So if we just draw a line here, and let's go ahead and get used to labeling it real numbers, we can have 0 here in the middle, and then we can plot any point that we want. So we're going to call these numbers points. So maybe I can put 2 right here. So this is a point. Here is my origin. So that's how we're going to plot on the real number line. So we'll see in just a little while in the next few sections how to plot in the Cartesian plane. This is different. This is just one line where we're going to plot real numbers. So what we can talk about with the real number line is distance. And that's where absolute value comes into play. So what is the distance? The distance between one number and another is the length of the line segment between those two numbers. So let's say I have this number line here. Let's draw my origin. If I want to know what's the distance between 1 and 5, what I do is look at the line segment connecting the two. And I say, how long is this line segment? Well, if we count, we can see from 1 to 5, I would go over 4 spaces to get there. So this length is 4. So the distance from 1 to 5 is going to be 4. Let's try a different one. Here's my origin again. What's the distance from -2 to 3? So let's draw the line segment connecting the two. If I want to connect these two and see how many spaces do I go over, I see I'm going to go over 1, 2, 3, 4, 5. So the distance between -2 and 3 is 5. Now what is the absolute value? So the absolute value is the distance from a point to the origin. So what does that mean? That means that I draw my number line. Here's my origin. Let's say that I'm looking at 7 over here. What is the absolute value of 7? That's going to be the length of this line segment. What's the length of that line segment? Just 7. So that's the absolute value. The notation here is we say the absolute value, which is 2 bars, is 7. Question, what is the absolute value of -3? Well, let's draw our number line. Here's my origin, here's -3. How long is this line segment? Well, from -3 to 0, that's 3. So the absolute value of -3 is also going to be 3. So that's how the absolute value works. It's just the distance from a point to the origin. Continuing this, let's do our formal definition. We say the absolute value of a number A. Well, if A is positive, it's just going to be A. So if A is greater than or equal to 0, it's just going to be A. If A is negative, though, then we want to take the opposite of that, so it'll be -A. So that's if A is less than 0. So a couple of quick examples. Absolute value of 5. We've already kind of looked at one just like this. 5 is positive. How far away is 5 from the origin? That would just be 5. Absolute value of -2. -2 is negative, so now I'm in the second piece up here of the piecewise function. So I'm going to take the opposite of -2, which gives me a +2. So what's going to be true about this absolute value? So these are going to be facts of the absolute value. Number 1, the absolute value always has to be greater than or equal to 0. You can't have a distance being negative, so the absolute value is always going to be greater than or equal to 0. What else can we say? Another property. The absolute value of A is exactly the same as the absolute value of -A. So the absolute value of 5 is going to be the same as the absolute value of -5. This just means that any number is symmetric about the origin. So here's my origin, here's A, here's negative A. What it says is that this distance is A, also this distance is A. Hopefully you can see that. These two line segments have the same distance. That's all this says. So absolute value of a number, same as the absolute value of the negative number. Last property that we're going to look at here is that the absolute value of a number times another number, so A times B, is the same as the absolute value of A times the absolute value of B. So if I have, say, as an example, the absolute value of negative 2 times 3, that's going to be the absolute value of negative 2 times the absolute value of 3. Absolute value of negative 2 is 2. Absolute value of 3 is 3. So I get 6. So that's how this last property is used. Now we've already talked about distance a little bit. We've already introduced the idea of absolute value. How are the two related? So distance between A and B is the absolute value of B minus A. So the distance between any two numbers is just going to be the absolute value of one number minus the absolute value of the other number. Now it's important to note here, it doesn't matter the order in which you subtract them, because B minus A, the absolute value of it, is the same as the absolute value of A minus B. This comes from this second property up here. The absolute value of A is the same as the absolute value of negative A. So it doesn't matter which one we subtract first, that's what we're going to be doing. So for example, let's find the distance from 2 to 10. A couple different ways I could do this. I could draw my number line and just see how many spaces do I go between from 2 to 10, or I can say that the distance, and this is how we're going to use notation, the distance from 2 to 10 is going to be the absolute value of 10 minus 2. 10 minus 2 is 8, so this is the absolute value of 8, so 8. So the distance from 2 to 10 is going to be 8. Second example. Let's find the distance from negative 3 to 5. Well, it doesn't matter which way we subtract this, or we could draw the picture, it doesn't matter. But the distance from negative 3 to 5 is going to be the absolute value. You can decide how you want to subtract this. I could either do negative 3 minus 5, or I could do 5 minus negative 3. Now here's where you want to be careful with your negatives. It's always one number minus the other. So it's 5 minus negative 3, or negative 3 minus 5. You have to take into account both of these negatives. Either way, the first one I'm going to get negative 8. The second one I'm going to get 8. But both of them are going to be 8. So let's put a box around that. So the distance from negative 3 to 5 is 8. Now we also could have seen this by drawing our number line. Here's my origin, here's negative 3, here's 5. How many spaces do I have between these two, or how long is that segment? You can see it's going to be 8. So the absolute value will give you the distance. If you want the distance between two numbers, all you do is subtract the two numbers. Order doesn't matter. Take the absolute value of it. So that's how we do distance. One thing I do want to note, this is kind of an important note here, just because we had that the absolute value of a product was just the product of the two, so that was number 3 on our facts there, this is not true. The absolute value of A plus B is not necessarily equal to the absolute value of A plus the absolute value of B. That's not necessarily true. Now, why is that not true? Let's take, for example, the absolute value of negative 1 plus 5. So negative 1 plus 5, that is 4. Absolute value of 4 is just 4. But what is the absolute value of negative 1 plus the absolute value of 5? Well, the absolute value of negative 1 is 1, so I get 1 plus 5, which is 6. These two are not equal. So just because I'm taking the sum of two things on the inside of the absolute value doesn't mean I can break them apart. So this is not necessarily true. Now, if both numbers are positive, then absolutely you can do this, but in general, you can't do this. But there is something we can use, and it's called the triangle inequality. So what does the triangle inequality says? It says that I can't necessarily break this up to be, start this over again. I can't necessarily break this up to be the absolute value of A plus the absolute value of B. I can't do that. But what I can do is bound it. I can say this is less than or equal to the absolute value of A plus the absolute value of B. That is something I can say. I can't say they're equal, but I can say that the one on the left is less than or equal to the one on the right. Now, where does this come from? Well, the name triangle is in the title, so it probably comes from a triangle. Let's say I just draw a triangle here. Let's call this side A, this side B. What I do know is that this side C here, it has to be less than the sum of these two. I have to have that happen. So C has to be less than A plus B. That's where this comes from. It says that the third side of a triangle has to be less than or equal to the sum of the other two sides. Alternately, the sum of these two sides has to be greater than this third side. So from the triangle, because of the way that the sides work, that's where the triangle inequality comes from. So as far as absolute values go, you're going to want to know what is the absolute value. That is how far away a number is from the origin. Distance is found using the absolute value and then subtracting the two numbers. And then the triangle inequality says that the absolute value of A plus B isn't equal to the sum of the two, but it is less than or equal to the sum of the two absolute values. So that's going to be it for absolute values.